Algebra Lesson 5-1. We've now gone over a few different ways of solving equations, and we've actually started into some graphing. We have multiple methods for graphing with our input-output tables, our x and y intercepts, and then the introduction of slope-intercept form. And the nice thing about slope-intercept form is that it can easily be adapted to some of the story problems that we've been working on, where some rate of change might be involved and some starting values, and how it might all come together, which is really kind of nice. You can approach story problems from multiple angles and have multiple ways of solving them. So the first thing I want to look at is what's called a linear model. We've been dealing with linear equations, and we know that linear, if we were to cover up the A and the R, says line. So this is a model based on a line. So this linear function, all right, remember a function is any number we plug in is going to continuously produce the exact same output, used to model a real life situation. M, as we know it, stands for slope. In a real life situation, that rate of change, all right, is how much it might be going up per month, or how much it might be going up per day. The amount of your salary that you get per month. Any rate that's constantly changing. Remember, it's not changing by, 1 month I make $100, the next month I make $200. It's the same amount. Remember that M, slope, is also the same as constant. So the constant and the slope, it constantly is changing at that same amount. The B value in y equals mx plus b is going to represent the starting amount, however much we begin with. If I put money into an account, say I put $200 into a savings account, and then I add to it every month $50 extra, the starting amount would be 200, my rate of change would be the 50. 50 more, 50 more, 50 more, 50 more. It's not changing every month, it's constantly that way. So in y equals mx plus b, we know that the starting amount, which is right here, the initial starting amount is this b value, and the rate of change is our slope. All right. For example, I could say $200 into it, which would be called a deposit, and I add $50 per month. Now, sometimes you can listen for a key word like $50 per month. It's a pretty good indicator that you're dealing with rate of change. So I would write this as y equals mx plus b, my starting amount. So you can take information that's given to you and you can still form slope-intercept form, which means we could then make a graph if we wanted to. We can make input-output tables. It's quite a bit. I could figure out how much would be in this account 10 months down the road, because I know if I just put a 10 in, 10 times 50 is 500, plus the 200 would make a grand total of $700 in the account. All right? So let's practice that. Write an equation of the line whose slope, m, is 3/4 and whose y-intercept, b, is -4. We know the generic form, y equals mx plus b. We simply have to be able to take the m value and substitute it in, and the b value and plug it in. If we can put things in the right spots, we'll be okay. Typical mistakes. People accidentally put the -4 right here. Sometimes people that put the -4 in for y, because they have y-intercept, they think that's what y is. Remember, this is a very specific y value. This is the y value when x is equal to 0, because if we're actually on the y-axis, we have a 0 for our x. So our final equation should look y equals that 3/4. We know that slope is rise over run, x plus -4. We've now taken this information, substituted it in where it goes for m and the b, and we're good. We don't want to put anything in for the x and the y. Alright, one more to look at. Write an equation for the following graph. Now it's our job to go the other way. You could have taken this and you could make a graph. You could say, well, I'd go on the y-axis, I'd go down 4 places and put a dot, and from that dot I'd go up 3, right 4, up 3, right 4, and you could make a graph from this. Now in our last example, I'm going to give you a graph, and we've got to take the information from it and write our own equation. The two most important pieces of information we need, we've got to figure out what's the m, what's the slope. We also need to know what's the b, what's the y-intercept. It should be easy to find the y-intercept. You just look at the graph and see where it crosses the y-axis. Remember, this is the y-axis right here. So therefore, our b value is right there at -1. So we just found the y-intercept just like that, where it crosses the y-axis. The slope, if you recall, m is rise over run. Now before I get carried away, one thing you want to look at is the graph going up or down. As you look at it from left to right, it appears to be going down, which means it better be a negative slope when we're done. So if I wanted to start here, I could start here and I could say, okay, it's got to go down. Looks like it goes down a whole 1 unit, because remember my increments are larger, so it went down 1. And then it turned and it went to the right, +2. So my rise over run is -1 over 2. And somebody might say, but I'm going the other way. I'm going to go up 1 and left 2. Okay. Up 1 and left 2 is the exact same -1/2 fraction. And it's negative, which is good as I look at it left to right. I have my m, I have my b. The last thing to do is write the equation. Simply y equals the slope, -1/2 x, plus the y-intercept, -1. I've taken the information and I've extrapolated it, pulled it off the graph, substituted it in places that I need it, which would be the slope and the y-intercept.